Hello everyone, this is Chadlac1, and welcome to Artificial Intelligence Essentials Part 1. Today we'll be discussing the enemy AI controller, the enemy pawn, and a BTTask. So sit back and let's make some AI. Okay, so we got the editor started up. It's just a simple blank third-person example project that's also in C++. Simple as that. Nothing too crazy, so let's go ahead and get started. So the first thing we're going to be doing is first we're going to be going to our blueprints. We're going to add new. We're going to add a Blackboard. We're going to call it enemy BB. BB for Blackboard. So now we're going to add a new key. We're going to have it be an object. Call it target. And we're going to set the key type on object, but we're going to set the base class to be an actor. Save it. Alright, so now let's go ahead and add another thing here quick. We're going to add a behavior tree. We're going to call it enemy BT. Open her up. And it should have everything there. Well, I think it does. We're going to repair it. Okay, there we go. And then we're going to save that out. And save all. Good to go. So now we need to remember target in particular for the enemy we're typing to, which would be the player. So now let's go ahead and go to add new. We're going to first start off with creating our AI controller class. So I'm going to call it AI controller class right there. And we're going to call it enemy AI. Create the class. I'm going to put it on pause while it creates the class. Okay, so we just got the enemy AI class to be created. So we're going to do one last couple of things here. First off, we're going to add another C++ class. We're going to add a character class. We're going to call it the enemy character. Create that class. I'm going to put it on pause while it creates. Alright, so we got the enemy character created, so we're good to go on that. So the first thing we're going to do for our character is add a behavior tree object. So we're going to make a new property. Make this be edit anywhere. Category equals behavior. And then we're going to make a class new behavior tree. I can spell behavior. And call it bots behavior. And that's all we need for this here. So now we add the behavior tree object here in our enemy character. Now we're going to move on to our controller class. We're going to be adding the two things here real quick. We're going to be adding the Blackboard component and the behavior tree component. So the behavior tree component is kind of like the thing that really communicates with the behavior tree to, understand what to do, that sort of thing. So we're going to do, the first thing we're going to do is a U property, transient. Transient means it's like when the object's already initialized and set it to 0, or just basically serializes it to the disk without having to. It's a weird way of putting things, but think of it as initializing it to 0 right off the bat. So we're going to say class U Blackboard component, and I'm going to call it Blackboard comp. And another U property, transient. And this will be the behavior tree comp. Behavior comp. Call it that. Add our public members. And we're going to have a constructor, a enemy AI. We're going to have our possess function. We're going to override it. Virtual void possess pawn and pawn override. Alright, so how I get this function here, how I know to override it, is because of this. Because we want to do add something new to the possess. So this is how I know where to go. I always go back up the tree to look around what things are what. This is kind of like how I discussed in the inheritance class stuff when I was in the previous video I've done. So I just kind of want to reassure you guys where I'm getting all this from. So I right click on the AI controller and go to definition and Visual Studio. Once the IntelliSense operates as progress, and we could actually see where I'm coming from. As you can see in here, so we'll take a look down here, find the possess function here. Just gonna hit Control F, possess. Gotta do here. Those are the blueprint implemented functions when you do possess. There we go. This is what I always go for. Virtual void possess override, meaning we could also use it for ourselves. So let's go ahead and continue on here. So we got virtual void possess. Now the next thing we're going to be doing is adding our key IDs. And these key IDs have to be an unsigned int, an 8-bit unsigned int. So we're going to say uint 8 enemy key ID. So next thing we're going to do, I'm going to put these in the .cpp file real quick. Put our constructor and that. Do a enemy AI, a enemy AI. There we go. And we got void a enemy AI possess. A pawn and pawn. There we go. Now we'll restart her again. The editor kind of crashed at me in the process of trying to get definition of the AI controller class, so we got to restart the editor real quick, and then I'll show you guys why we need that enemy key ID. I'll try to explain while this is loading. So basically what we're going to need is the key, the Blackboard key from the editor, which is target, which target is being the object, which the uint8 is just getting the ID of it. That's how we get the Blackboard objects in C++. And I'll definitely show you here real quick. It's just going to take a little bit longer. I'm going to pause the video while it loads up. Alright, the editor's back up. So let's go ahead and go back to our behavior tree in our Blackboard. So go to the Blackboard. So see it says target and it says keys. This is the reason why we need to get the key, because we get the key ID, which is target. And that's what we're going to be trying to achieve here today. So now we're going to go to the enemy AI.cpp, and then run our constructor. We're going to initialize our Blackboard component and our behavior tree component. So we're going to say Blackboard comp equals create default subobject, which would be the Blackboard component. I'll call it in the editor Blackboard comp. There we go. And now we're going to do the same thing with the behavior tree comp. Behavior comp equals create default subobject u behavior tree component. Call it behavior comp. And that's all we need to do in our constructor. Good to go on there. So now on possess, this is where most of our logic is going to be happening. But in order for all this, this didn't work. So behavior tree component. There we go. Now I won't complain. But first, we got to do a few things to make this work. Number one, if we're going to be using AI, we need to go to our build.cs. Why we need to do this? Because we need to include the AI module, which I just included here a bit ago. In our add range, we need to include our AI module, which we're all good to go there. But be sure you do that, or else your AI is not going to work. So we need to include these particular header files. There's quite a bit, so bear with me here. Include behavior tree, .h, because we need to have the behavior tree. We're going to be typecasting to a tree from our character class. Include the behavior tree folder. We include behavior tree component. .h, and then we also need to include the behavior tree folder. And we also need to include the Blackboard component. .h, and then we need to include behavior tree folder and the Blackboard folder in here, which we also need the Blackboard key all types. All types.h. The reason why I put all types because I don't want to put behavior tree get Blackboard object. I'm just going to do that for now. It just makes life a lot easier. So now we can well, before we do that, we got one more thing to do. We got to also include the enemy character. .h. So now we could get our character when we possess him. So we're going to say in our enemy AI possess function, we're going to say super possess. And we're going to put in pawn so we can override it. Now we need to get our character. So we're going to say a enemy character. We're going to call it char equals cast a enemy character. So we need to type cast to the character, and we're going to assign this value in pawn. Because in the editor, we could assign, I'll show you. So in the editor, we don't have to worry about saying a begin play or anything like that. Because I'll go to third person character, for example. So we open the full blueprint editor. So we select this guy here, and you see in the AI controller class, we could by default set our AI controller class without having to do it in C++ if you don't want to. But you can, but it's just easier to do it this way with using possess, so we already know who it is. So now I'm actually going to close out this too. Now let's go ahead and continue on. So we're going to say if the character does not null and if the character bot behavior is not null, we are going to start the Blackboard. You're going to initialize it. Comp initialize Blackboard. And we need to dereference the this here, bot behavior, Blackboard asset. There we go. Sorry, my telesense is a little slow. The next thing we're going to do, we're going to need to assign the enemy key ID to a particular object from our Blackboard. This is what I was talking about earlier when we say enemy key ID equals Blackboard comp. I'm going to say get, what was I going to say? Get key ID, that's right. Get key ID, which is target, which is the name in here, in our Blackboard. As you can see, target is our name for our ID. So I'm going to exit out of the Blackboard as well. Go back here. So now, once that's all taken care of, now, once we're possessed, we want to start the behavior tree to start doing particular behaviors. So we're going to go to behavior comp start tree. I'm going to dereference this as well. So we just get its base. And there we go. That's all we need for the enemy AI controller portion of it, because it's no different than doing it in Blueprint, because you need to assign your keys to be particular objects in a way. You can do the same thing. Say, for example, you have waypoints. You can do the exact same thing, but we'll do the waypoints in the next tutorial and do a little bit more crazier logic. Right now, I'm trying to create a base, set move to when the character, the enemy enters into the game, you want to chase the character. So now, next thing we're going to do, we're going to compile the code. I'm going to pause it real quick, and I'll be right back. Alright, the code is now compiled. We're all good to go. So we're going to do a couple things. We're going to add two blueprint classes that we just created. So we're going to say enemy AI. We're going to call this enemy AI underscore BP for blueprint. And we're going to do the same thing for the enemy character. Say enemy character and enemy character BP. There we go. Save it all, because always save your shit. So now, in our enemy character BP, there's a few things we're going to need to do. So at the very top, when we select enemy character BP self, we're going to see behavior, bot behavior. We're going to assign it the enemy BT, which is what we created earlier. In the AI controller class, we want it to be the enemy AI underscore BP, so it automatically possesses when we place it into the world. This makes life so much easier. So now, as you can see in the enemy AI BP, we now have a Blackboard comp and a behavior comp. Since they're transient, they're not going to be able to do anything to it. That's what we really want, because we don't want to assign it anywhere else. We just want to do it once we enter in a game. So now the next thing we're going to be doing, we're now going to create a we're going to create a BTService. So now we're going to go to new C++ class, show all classes. We're going to say BTService. I want to use a BTService based class. So we're going to call it, and also another thing you got to do, BTService underscore whatever you want to name it, because if you say that, it'll identify in the editor without having to do anything else. Because if you don't do that, it will not know it's there. For some reason, that's just the way it's always been, and it's always going to be that way. So we're going to say check for player. And to really understand what a service does, a service is like, and what it does, it kind of checks every update. It's kind of like a service is like, if you're going to find something in the world or going to do something, you're going to be doing some sort of checks to find out where something's at or how something's going to happen. That's what a service is kind of what really does. That's the only one I know that actually has a tick function to be able to like, hey, we're going to be doing something every tick to do something, or you turn on and off, that sort of thing. So now, let's go ahead and explain the BTService particular things. So we're going to go to definition of BTService, and we're going to take a look at a few things. Let's hope the editor doesn't crash on me this time while I'm looking for the operations for BTService this time. Because there's a node in there that it says it's a tick node, and we need to call that function. Let's see here. Where is tick? There it is. Virtual void tick. So basically think of this as in behavior tree. So I'm going to actually do that real quick. I'm going to go back to here. Let's go to content. So we're going to add new blueprint class BTService. BTService blueprint base. I'm going to say select derpy stuff, whatever. We're going to call it that because I'm not going to use it. So think of it as we're going to say tick event receive tick. That's basically what this guy is. In the if you actually try to create a blueprint based one, you'll see in there has event receive tick, but you can't override because it's a blueprint implementable function. That's the reason being we use the straight up BTService. So I'm going to compile that and I'm going to delete it because I don't need it. So let's go ahead and go back to the BTService, and we're going to do, actually I'm going to go back to that quick. I need to grab this function here because we're actually going to be overriding this function exactly the same way we want to. Okay, so let's go ahead, go to public virtual void BTService and override, and also we're going to make a constructor because we need to do something. BTService check for player. There we go. Got a constructor. Now let's go to our CPP file. I'm going to say BTService. I don't want to do this because I'm typing it out. Oh my gosh, whatever. I'm just going to type it out. Check for player. I'm sorry if it's painful to watch me type bad. But there's a thing in there we have to do that's really essential. Because we need to make it a node instance. Because if you want to put this on multiple AI, you got to create this as a node instance. So we're going to say b create node instance equals true. That's all we need in our constructor. So now let's go ahead and move on to our tick node. We're going to grab this, get rid of virtual and override because we don't need those. Same thing with semicolon. We're going to say BTService underscore check for player scope, and there we go. Now this is where all the magic happens. But we're also going to need to include the same stuff from before, which is a lot of this stuff in enemy AI. We're going to grab all this here between this, all the behavior tree stuff, and the enemy character because we might need it. I'm thinking we're going to need it, but I'm going to double check. I know we're guaranteeing we're going to need include enemy AI.h. We're going to need that because we need to call it from the owner comp inside check for player. It's a parameter inside tick node. So in order to, because the thing is when you do tick node, if you remember, you can't, with owner comp, you always have to get the player controller. You can never get the actual actor. We can't typecast to the pawn. You always want to typecast to the controller. That's how the tick node works. So in order to do this, we're going to say a enemy AI. Let's say char enemy PC. You're going to enemy player controller equals cast a enemy AI, and we're going to say owner comp, which is right up here in this parameter, which is a behavior tree component. We're going to say dot, because it doesn't have a pointer reference. So we're going to say dot. We're going to say get AI owner. So that's how we get the AI controller class. Now the next thing we need to do, we need to check if it's there. We're going to say if enemy PC. We're going to do this. We're going to say, now next thing we need to do, if we need to check, because in this check for player, what we're going to do, we're going to check if the player's in the world. That's essentially what we're going to be doing. So we need to get another include here. I'm going to say include AI essentials character.h. And we're going to say AI essentials character enemy equals cast AI essentials character, and then we're going to get world, get first player controller, and then we're going to get pawn. And that's it for that portion of it. Oops, if I could spell my casing right. There we go. Now we check if it exists, if enemy, if it exists, we are going to assign the Blackboard component. Now in order to get the Blackboard component in here, in the BTService, we have to do this. All we have to do is say owner comp dot get Blackboard component. The next thing we do, we're going to say set value. Okay, there's a weird thing they do now, because they used to have say get value as bool, class, enum, object. You have to do it completely different now. I'm not sure what Unreal is doing, but they have to do this thing. Value, view, Blackboard, key type, and then we get object. And then type is basically like dynamic cast to it, and then we get the enemy key ID from the player controller. That's where we stored it, which is of course right here. Int enemy key ID. So now the next thing here, we're going to say enemy key ID. Oops, enemy PC, enemy key ID. That's the first thing. It requires two parameters. The second part is the actual data type field value. What's the value of this object? Which is of course enemy. And that's if it exists. And that's it. That's a service. Now we can check for the player on every tick. So now let's go ahead and compile this. And I'll be right back once it's done compiling. Okay, looks like we got some errors here. So let's take a look what's going on here. So it says check for players, not a class or namespace type. I spelt it wrong. Yep, I spelled service. Need a V, service. That should work. There we go. Now it should compile. Get a quick one. Looks like it's compiling a lot faster. Because for some reason, when I first make a project, it always takes forever on this first compile. I have no idea why. But once the hot reload's all good to go, I usually just like plot. It's always compiling fast. So it should be good to go here. Predicting. Alright, good to go. Cool. Now, so the coolest part about this, since we created it the way we did, so we'll go to enemy BT, the actual behavior tree. So we're going to make a selector. We're going to right click on the selector and add service. And it says check for player. Do not use this one, use that one. This is an instance of it, but the reason why I had the instance of it is because in case we want to create it differently. So you'll check for player. And everything's all there, so you don't have to worry about putting any sort of like Blackboard stuff in there. It's already in there because we're looking for it already. So now what's the next thing we need to do? We need to create a task. That's our next task. The puns. All right, so let's go ahead into add new. We're going, actually first off, let's do something real quick. I just want to double check if the AI knows it's there. So I'm going to double check. Let's go to AI Essentials. Okay, if it says engine minimal, switch to engine in your AI Essentials.h or whatever game name.h you have. So what we're going to do, we're going to say gengine add on screen debug message. 1, 2.f, make it green. And then we're going to say I exist. Enemy, I should say enemy is here. There. And we're going to compile that real quick. I just want to make sure the checks are working. I just want to show it visually so be reassuring. Each step we're taking is doing something. Because there's no more fun than just being like, okay, we're going to make the whole thing, just put it in there. It's like, well, how did this work? How did that work? That's what I want to show you guys. So now we got that SOB working. We're going to put this into the world. And we're going to add a cube to this little guy because I have no mesh to want to use right now. So we're going to say, we're going to make the scale at 0.5. There we go. Oops, I need it on all of them. 0.5 and 0.5. Cool. And we're going to save that out. Save all. Always save all. So then we're going to hit play. Enemy is here. It knows we exist. That means the behavior tree knows what's up. Let's go to the behavior tree itself. And let's go to enemy AI. Knows it's here. It's going to it. It's not going to show up because there's no other task below it. So it knows it's here, though. It knows we're doing something. So now the next thing we're going to do is create a C++ task. So let's go to BTTask. I'm going to Blackboard base. For some reason, the Blackboard base ones work, but if you do a task node base, for some reason, it just won't identify an editor. I don't know why. It's just the way it is. So I'm going to say BTTask. Like I said before, this little notation here matters so much to actually be identified in the editor. We're going to call it move to player. I'm going to create it. I mean, what we could do is just do a simple move to, but I want to show you a little more how tasks are done. That's the reason being I'm doing it this way. It's going to be simple, like if the player exists, if it's there, go to the player. And I'm going to hit pause real quick while it creates the code. Alright, so now we created our task object, move to player. So now, let's go ahead and take a look at the Blackboard base here. We have to keep going back down the chain to take a look at a few things, because I want to show you what exactly we're doing here with the task, because we want to look for execute task. In the blueprint node, it's technically called execute, but we're going to see in here, it should be called execute task. Alright, there's a task node. It's not going to be in here because it all derives from that. So we're going to say go to definition. You should see a EBT node result type execute task. It's a weird kind of a return type, but it checks. The reason why it does a particular, the node does a particular thing and returns if it succeeded or failed. That's basically what we're accomplishing here. But we're going to need this. We're going to grab it, copy it. And we're going to go to move to player and Control V, and we're going to override it. We're going to make this, yep, there we go, public. There we go. So we have it. And one thing I like about Visual Studio 2015, when there's a little light bulb comes up, you can create definition just by default for you. You don't have to worry about it typing it out sometimes. I don't know. That's what I like to do. Oh. Now it's telling me it's not liking it, but I'm going to make it work because it is a function. It's probably because I did it too soon when I did it, but we're going to say BTTask move to player scope into execute task. So now, first thing we're going to be doing in our task is we're going to grab a few things. We're going to grab these guys, or if I can find it, these guys here again. just in case, we're going to go put them in between the AI Essentials.h and a BTTask move to player.h. Put them all in here. Yes, we're also going to need the enemy AI.h, and we're going to need the include AI Essentials Character.h. Cool. Now we got those. Now, the first thing we're going to do, we're going to grab our controller. Same thing like we did in our check for player. We're going to have to use the owner comp to get the AI owner. So we're going to say enemy AI, enemy PC equals cast enemy AI owner comp dot get AI owner. There we go. And then the next thing we're going to do is we're going to get the particular value. We're going to say AI essentials character. We're going to get the character, and then I'm going to say, I'm going to say enemy PC. You're going to say char PC. Char PC. I like that better. So we're actually communicating with what? Enemy equals cast AI essentials character. Now this is a doozy. So we're going to get the owner comp dot get Blackboard component, and we are going to get value, and then of course this little guy here, the little U Blackboard key type, because that's what they're changing nowadays. And we're going to say which key ID. So we need to go to the char PC, which is where we stored our enemy key ID. Now, so let's recap there. We are trying to find out the enemy object. We're assigning it the value we stored it in the Blackboard. Get value object, which is the enemy key ID from the Blackboard. So now, next thing we're going to do, we're going to say if enemy, if it exists, if there's anything in there, we're going to say char PC move to actor. And it has a lot of things in here, but it's not too scary. It's just wanting the goal of the actor we're moving to, which is, of course, enemy. We're moving to the enemy. Acceptable radius, you know, the 5-point F. And then we're going to make sure it's around that radius so it doesn't get too close. Stop overlap, true. This will come in handy later. Use pathfinding, definitely true, because we're using a nav mesh. Can strafe? Yeah, let's strafe. And the navigation query, we don't have a query yet, so we're going to set that to 0. Allow partial path, true. There. And then after that, we need to return something. We need to say return EBT node result. Scope, and we're going to say succeeded, because it needs a return type of this. And if it does not have it, we're going to say return EBT node result failed. And at the end of it, we're just going to double check EBT node result failed, just in case. So now, to recap, we get the player controller from getting from the owner comp from the AI owner. We get the character, we cast it from the Blackboard value inside the owner component, which is obviously the AI. If the enemy exists, we're going to move to it and return that we succeeded. So let's go ahead and compile this. I'm going to pause it once it's compiling. Alright, just got done compiling. Looks like everything seems to be in order. So let's go ahead and go to content, third person, blueprints, and let's go to our enemy behavior tree. So once we extend, we pull down, we hit task, we should see a move to player. Everything should be all set in order. We can rename it whatever we want, say move to player. Bingo, done and done. Save it out. And a couple things we're going to need to do. It's not going to move anywhere until we put a navigation mesh in here. So we're going to say nav in our search and B modes, and mesh bounds volume. Pull her down and put the bounds value size. Sure, that'll do for now. I'm going to save all. Always save it. And let's hit play. And look at that. It's following us. It's following us. This was all done in C++. I hope you guys learned a lot today. But the next segment, we're going to be talking about BT decorators, and we're going to be talking about a spotted search and destroy AI, and we're going to be constructing that from the ground up. And this is just the base. I really hope you guys enjoy this video. Please subscribe, and I hope to see you next time.